Drawing Simple Venn Diagrams Introduction. So welcome to this section on Venn diagrams. As we begin, let's understand why we're learning this. Venn diagrams are incredibly useful. They're powerful tools for visually showing how different groups, or what we call sets, are related to each other. Think of it like a map for organizing information. Now, in this tutorial, we're going to focus on drawing the basic Venn diagrams, the ones that compare just two sets at a time. I'll walk you through each step carefully, making sure you really grasp the process. We won't just be drawing shapes, we'll be learning how to represent information clearly. And a really important part of drawing these diagrams correctly is labeling. We'll be paying close attention to how we label the universal set, that's everything we're considering, and then the individual sets themselves. Getting these labels right is absolutely crucial, because it ensures that anyone looking at your diagram will understand exactly what it represents. In the following slides, we'll start with the materials you'll need, and then we'll jump right into the step-by-step drawing process. Drawing Simple Venn Diagrams Materials Needed. Alternatively, if you prefer working digitally, you can use a drawing tool on a computer or tablet. Next, you'll need something to draw with: a pencil or a pen. A pencil is great because you can easily erase mistakes as you go. A pen is fine too if you're confident in your drawing. Finally, we have a ruler. The ruler is listed as optional, but I highly recommend using one. It's not essential for the mathematical correctness of the diagram, but it will help you draw straighter lines for the rectangle and circles, making your diagram much neater and easier to read. Remember, a clear diagram helps with clear thinking. So now that we've discussed what Venn diagrams are and why they're useful visualizing relationships between sets, let's move on to actually creating one. This slide, titled Drawing Simple Venn Diagrams Materials Needed, is pretty straightforward. It simply lists what you'll need to draw your diagram. In the next step, we'll actually start drawing the first part of our Venn diagram, the universal set, so have these materials ready. Drawing Simple Venn Diagrams Step 1. Draw the universal set. So now we're moving on to the first actual step in drawing our Venn diagrams. As we discussed in the introduction, Venn diagrams help us visualize relationships between different groups, or sets, of things. And to do that effectively, we need a way to represent everything we're talking about. That's where the universal set comes in. Think of the universal set as the big picture. It encompasses absolutely everything that's relevant to the problem we're trying to solve. It's all the possible things we could be considering. Now, traditionally, we represent this universal set with a rectangle. So, what I want you to do is, take your pencil and draw a fairly large rectangle on your paper. Make sure it's big enough to comfortably fit the circles we'll be adding later. This rectangle is going to act as a boundary, containing all the elements, all the items or individuals that we're working with in this particular scenario. Once you've drawn your rectangle, we need to label it. We represent the universal set with the letter U. So, write U clearly inside or very close to the rectangle. Alternatively, you can write out universal set if you prefer, especially when you're first starting out. Remember, this U or universal set is the foundation of our diagram. Everything else will be contained within it. In the next step, we'll start adding the circles that represent our individual sets, and we'll see how they fit inside this universal set. So, take your time with this step, make sure your rectangle is neat, and your label is clear. Drawing Simple Venn Diagrams Step 2. Draw the circles for each set. So now we're moving on to Step 2, and this is where we actually start building the core of our Venn diagram. As you remember from the previous slide, we've already drawn and labeled our rectangle representing the universal set. Now, inside that rectangle, and this is important inside, we're going to draw two circles. Imagine these circles representing our sets. Let's call them Set A and Set B, which we'll label in the next step. The key thing here is that these circles must overlap. The area where the circles overlap is incredibly important because it represents the elements that are common to both sets. So, those elements would belong to both Set A and Set B simultaneously. Now pay close attention to this next point. We don't want the circles to be completely contained within each other, nor do we want them to be perfectly separate. We want parts of each circle to extend beyond where they overlap and into the rest of the rectangle. But, and this is crucial, all parts of the circles must remain within the boundaries of the rectangle. What does this extension beyond the overlap represent? It shows us the elements that are unique to each set. So, the part of circle A that doesn't overlap with circle B represents elements that are in set A, but not in set B, and the same applies to circle B. This ensures we can visually represent all possible scenarios for elements within our universal set. We'll build on this in the next few slides by labeling the sets and then understanding exactly what each region of the diagram tells us. So, take your time with this step, making sure your circles overlap and extend appropriately within the rectangle. Drawing simple Venn diagrams step 3. Label the sets. Now we need to identify what each of those circles represents. This slide tells us to label one of the circles as set A. When I say set A, think of it as a group of things that share a common characteristic. Write that label, A, clearly inside the circle or very close to it, so it's easy to see what the circle stands for. Next, we label the other circle as set B. Just like with set A, set B represents another group with its own characteristics. Again, make sure you write B clearly inside or near that second circle. So now we're moving on to step 3, and this is where we start giving our Venn diagram some meaning. As you remember from the previous slides, we've already drawn our rectangle representing the universal set, and then we drew 2 overlapping circles inside that rectangle. It's really important to be neat and legible with these labels. If your labeling is messy, it will be hard to understand what the diagram is showing. Remember, we're building a visual tool to help us understand relationships between groups, and clear labeling is key to that. In the next slide, we'll be diving into what each of these different sections within the circles actually means, so getting these labels right now will set us up for success. We'll be talking about intersections and elements unique to each set, so keep that in mind. Drawing simple Venn diagrams step 4. Understanding the regions. First, let's look at where the 2 circles overlap. This overlapping region, right in the middle where circle A and circle B intersect, represents all the elements that are in both set A and set B. Think of it as the things that belong to both groups. In mathematical terms, we call this the intersection of A and B. We write this as an intersection B, and it's often written with a special symbol, A with a curved line resembling an upside-down U connecting it to B. Next, consider the part of circle A that doesn't overlap with circle B. This section represents all the elements that are in set A, but not in set B, so these are things that belong to group A, but not to group B. Similarly, if you look at the part of circle B that doesn't overlap with circle A, that represents all the elements that are in set B, but not in set A. These are things that belong to group B, but not to group A. Finally, let's look at the area outside both circles, but still inside the rectangle. Remember, the rectangle is our universal set. This region represents all the elements that are not in set A and not in set B, but are still part of the overall group we're considering, our universal set. It's everything that doesn't fit into either of our specific sets. So now that we've drawn our Venn diagram with the universal set and the 2 circles for sets A and B, let's break down what each region of the diagram actually means. This is really important for understanding how to use Venn diagrams to solve problems. Understanding these regions is key. In the next slide, we'll look at a real-world example to see how this all comes together, and then we'll recap the main takeaways. So, make sure you've got a good grasp of what each section of the Venn diagram represents before we move on. Drawing simple Venn diagrams example. So, let's say our universal set, which we denote as U, represents all the students in a class. Imagine we're surveying this class about their favorite subjects. Now let's define our sets. Set A will represent the students who like mathematics, and set B will represent the students who like science. Remember, we use capital letters to denote sets. Now, think about how this translates to our Venn diagram. the area where the circles for set A and set B overlap, that's where we would list the students who like both mathematics and science. They enjoy both subjects. The portion of circle A that doesn't overlap with circle B, that represents the students who like mathematics but don't like science. They're math enthusiasts, but science isn't their cup of tea. Similarly, the part of circle B that doesn't overlap with circle A represents the students who like science but don't like mathematics. They're science fans, but maybe math isn't their strongest subject. Finally, the area outside both circles, but still inside the rectangle, that's crucial. This area represents the students who like neither mathematics nor science. They might prefer other subjects like history, English, or art. Let's solidify our understanding with a practical example. As you recall from the previous slides, we've learned how to construct a basic Venn diagram with a rectangle representing the universal set and circles representing individual sets. Now, let's apply that knowledge to a real-world scenario. So, by visually representing this information in a Venn diagram, we can quickly and easily understand the relationships between these different groups of students and see how many students fall into each category. This is a powerful way to organize and interpret data. In the next slide, we'll recap the key takeaways from this tutorial, so you can remember the most important points. Drawing simple Venn diagrams key takeaways. Let's recap what we've learned about drawing Venn diagrams. This slide summarizes the key takeaways, and it's important you understand these points thoroughly before we move on to practicing with more complex examples. Firstly, remember that the rectangle we draw always represents the universal set. Think of the universal set as the entire collection of things we're interested in for a particular problem, everything under consideration. So the rectangle encompasses, that means includes all of those elements. Next, the circles inside the rectangle each represent an individual set. Each circle contains elements that belong to that specific set. We've already seen how we label these, haven't we? Set A, set B, and so on. Now the really important part, where the circles overlap. That overlapping region represents the intersection of the sets. If we were to write that mathematically, it would be an intersection B. What that means is, it shows all the elements that are present in both set A and set B. It's where the two sets have something in common. Finally, and this is something I see students often overlook, proper labeling is absolutely crucial. Make sure your universal set is clearly labeled, and each of your individual sets, A, B, and any others you might have, are also clearly labeled. This isn't just about neatness. It's about making sure anyone looking at your diagram, or you, when you come back to it later, can immediately understand what it represents. Clarity and understanding go hand in hand with good labeling. All right, on the next slide, we'll look at some common mistakes students make when drawing Venn diagrams so you can avoid those pitfalls. But first, make sure you've got these key takeaways firmly in your mind. Do you have any questions about anything we've covered so far? Drawing simple Venn diagrams common mistakes. Remember from earlier slides, the rectangle represents our universal set, everything we're considering. The circles represent the individual sets within that universe. If any part of a circle goes outside the rectangle, it means you're including elements that aren't part of your overall consideration, which isn't correct. So, double-check that all parts of both circles stay neatly inside the rectangle. It's really important to write labels that are easy to read. Clearly label the rectangle as U, that's just the letter U, standing for universal set, and label the circles as A and B. If your handwriting is a bit messy, take a little extra time to make sure the labels are legible. A messy diagram can lead to confusion, even if you understand the concepts. We started by drawing the rectangle for a reason. It provides the context for everything else. If you skip the rectangle and just draw the circles, it's like you're floating the sets in space with no boundaries. Always begin with the rectangle and label it as the universal set. This is where understanding what each part of the diagram represents is crucial. Remember, the overlapping area is where elements belong to both set A and set B. The parts of each circle that don't overlap represent elements unique to that set. And the area outside the circles, but still inside the rectangle, represents elements that belong to neither set A nor set B, but are still within the universal set. Take a moment to review Slide 6 if you need a refresher on these regions. So now we're looking at some common mistakes students make when drawing Venn diagrams. Paying attention to these will really help you solidify your understanding.